one of the very popular research area right now in the large language model. Yeah, but calling full assistant, I think is still not yet that mature because of the setups and also the context. And usually these full assistants, they are not automatic. They are more like interactive. They are more to be interactive. So calling full assistant is still a way to go.
Do you have good references for interactions with the tools you just described, like the Z3?
Yeah. There's a, although I think there are actually quite a few of them. I'm reviewing such papers daily, so there's people are really trying to. So the use with large language models, people as experts, they care about many of the reasoning tasks, because many of the traditional NLP tasks like summarization, machine translation, they have been cracked down by those large language models. NLP researchers, I believe many of them are not very happy, but these large language model researchers, they just want to push the limit of the reasoning task. So there's math reasoning is a very popular topic, I believe, right now in the machine learning community, and so we have a math AI workshop, which is this paper has been accepted. So there are a lot of papers. So 2 years ago there are almost 30 or 40 submissions, but I think this year is, I believe it's 70 or even more submissions. And then these machine learning researchers, they care about the reasoning abilities of large language models. Again, so they have some math puzzles, informal ones mostly. Also, I think Jeremy also loads these AIMO problems, which is also informal. And then these researchers, they are trying whatever they can to push their the limit of the performance of these models. So this tool use is one of the things they are starting extensively. So just to, and also, yeah, it's not just tool use. Right now, I think there are some researchers, it's about use these tools to have feedbacks, to generate feedbacks, and then the signals to fine tune these models so they can eventually be better at some of the tasks they were not very good at before.
Yeah, I mean, since you were talking about the tasks that the NLP guys kind of like, I haven't seen that much on natural language inference. Have you seen, I mean, for mathematics? I think that is one of the directions that, we should put some effort into, because, most of us kind of really reason informally, kind of. And I haven't seen data sets or things like that for that quite yet. If you have seen some, please send them my way.
Okay, sure. So you mean data set to measure the
natural language inference for mathematics.
Oh, that's
right, because of course there are loads of data sets for natural language inference, but they tend to be about kind of generic things. Some of them are for law and stuff like that, but I haven't seen anything much in the direction of mathematics.
Okay.
So yeah, okay. I'd be interested.
Yeah, okay, I'll keep an eye on that. So I'm not a pure NLP researcher. So I don't. To me, this math. NLP for math is a super niche field.
It is, yeah.
Yeah, I don't know in this direction yet, but I'll keep an eye.
Sure.
Isn't a data set for you to just take 20 textbooks, because you have the natural language proofs in them. Well, what else do you want?
Well, I want things that are annotated with, this really follows from that, and this is a contradiction of that, and this is neutral in respect to that, because, it's not, this sentence in this proof does not prove the next sentence. There's a gap there, so it's a neutral, perhaps. So, you see, there is a specific natural language task called NLI, right? And for that, what we're doing is kind of trying to check whether one sentence follows from the other, or is contradictory to the other, or is neutral. And a proof should be something that goes statement follows, statement follows, statement follows, statement.
Do you have a definition for this natural language inference? Because like
Well, there's dozens of systems that do that, and it's a very established task in NLP processing. But it's done normally over text, over newspapers. It's not done over mathematical text. That's why he was saying it's a very niche subject, and kind of it's one of the things that I think we should invest perhaps some of our time thinking about it.
So one thing I wanted to sort of bring this back to, and a little bit related to natural inference, is like when you demonstrate this draft to prove you use Isabelle, and then you have this three-step procedure where I guess the first thing is you break it down into a bunch of small statements. The second thing is you translate the language into the language of Isabelle, and you have some holes. And then the third step is that you basically just call sledgehammer on all the goals. Mm-hmm. Now, suppose that instead of targeting Isabelle, you targeted like push. In that case, the third step would be done for you. That's just the design of the system. Yeah. And the second step is a lot easier because it's natural language instead of like instead of Isabelle syntax. So like maybe rather than trying to target, like a formal language, you target something that's more like a controlled natural language, or possibly customizing the natural language
for the draft
for the draft and possibly the sketch. I'm not actually sure. Maybe there's just one step at that point, right?
Yes.
Because it's kind of the same thing.
Yes, because
the draft could already be the sketch.
The structured language is already a sketch.
Yeah.
Yes.
Yeah, thanks a lot. Yeah. Very good suggestion. I do believe this would improve the performance. Yeah, maybe. But one of the main issues, one of the failures, I think right now is like the gap is too big. So that none of the AGP is in the approach, I believe is E, and the interview is collection of them. Like none of them can bridge the gap. So how can we? Like ideally, we hope this model like humans, we can always break complex tasks into simple ones, divide and conquer. Yeah, I think again, I believe this is a very good suggestion. They can improve the performance, but I hope in the future we can have something.
To what extent can you prompt these systems to keep filling in gaps?
Sorry, what?
To what extent can you prompt the system to pick a gap and say, explain to me why this follows from that? And then get it to put more things in there.
Okay. Yeah, I think that could be one of the
right. Like one of the pieces of information you get from running the system is, oh, this gap is too big. Mm-hmm. This gap I was able to figure out, and so you can take the ones where the gap is too big, and then tell me put more things in there. And then that gives you an iterative system that maybe gets you more pieces of it filled out.
Yeah, I think is one of the things we were doing right now. So just ask for some more details. Yeah, but it surely helps. But maybe it's just one shot, and we don't know if there's a systematic way to do the things recursively, and also there's always a limit. I think there's how small, in the end, we don't know if the large language model will saturate in dividing.
There's a second observation I want to make though, which is that for me or for other people who are used to working with ITPs, I don't actually expect it to get the whole proof all at once, and it's totally okay if it's only able to prove 80% of the proof and gives me the interesting bits. Like that sounds great, right? That's an actually useful tool. And yeah, it's not necessary to aim for 100% on this task.
Okay, I see. Yeah. Very good suggestions. Yeah, that's so it's like use large language model to give us a partial proof. So there could be some holes for the hard part, and and then leave the users like the hard part. But yeah, I think that is something we can have in the future.
Yeah, so
I played a lot with ChatGPT, and so there's touch hub and there's quick check, right? So instead of just asking fill in the details, I always would ask the model, which of the two cases are we in? Did you make a mistake and this is actually not a valid step because the proof might be totally wrong? Or did you, can you explain it in more detail or something like that? And then the model will, might say, oh, by the way, this actually didn't work or something like that.
I think, yeah, this is an interesting direction of research. I believe it related to so-called self-critique or self-consistency. In our pipeline, we haven't implemented that yet.
Well, ChatGPT would be the wrong tool because the moment you express doubt, it will say, "Oh, I'm sorry, this was wrong."
Yeah.
I mean, it's tuned to be super careful because people don't want, the people who made it don't want people to believe everything it says. So I had a question for you about your interactive experiment. Was that just was that just the ChatGPT that we also play with when we just go to the OpenAI website, or was it a special version of it? Because my experience with ChatGPT is if you do follow-up questions, it just does epsilon little changes to the thing it already answered. You get the answer again with some little. So generally, what works much better is not to do follow-up questions, but ask the question again, and you get a different answer, and maybe that's a better one. So, but maybe you didn't use the vanilla user model that normal people use.
We did use the vanilla one.
Yeah, I'm not sure what's your experience, but I'm also using this ChatGPT daily, and to me, it's if the previous question is not in the prompt. And I don't think they will like fine-tune the weight will be changed.
Well, in my case, if I do something, I ask a follow-up question and I get another answer. When I compare these, they're very similar texts.
Okay, I don't know.
You should look at it. I mean,
I haven't observed that yet.
It really starts again with some minor variations. Anyway.
Okay.
Any more thoughts or questions or comments?
One other question about the definitions. You said at some stage the definition that the LLMs were very good at definitions. How did you discover that was the case? I mean, how did you separate the bits relating to definitions to the rest of this stuff? I'm not hallucinating, right? You did say the definitions were good.
Yes, the referral to the definitions was extracting the definitions from LLM was good. Yes,
right.
Was helpful. The mathematicians found
it helpful.
Yes,
right. But you didn't then create a data set of definitions that had been hand checked by the mathematicians, or did you? And if so, can I have it?
No, we didn't. But we have all the interactions, so
you could do that.
So we could do that. Yes.
If possible, it would be nice.
Two more things.
Yes.
One is you said it should be less verbose and explain more. The nice thing about large language models is you can just tell them. So there's this standard prelude that we don't see, but that OpenAI has there, and people have been uncovering it by prompting in the right way. But you can do this too.
Yes.
You are very terse. Explain everything you do. Say it a couple of times so it won't remember.
It's a whole field of prompt engineering.
Exactly, but that probably will help a bit with this problem. Yeah. And the other thing is with your translation with the 00 and so on. What you can do is to ask first, okay, take all the parts of the sentence and give Israel translations of all those parts. And then as a second prompt, now assemble it in two, and then you help it not hallucinate too much because you force it to explain why it thinks that it should be like this. So that's what I would try. Like, okay, you can just with this sentence with even and so on. And see what it comes.
I think that makes a lot of sense. I know right now there's a research direction called proof in context agent. So it can treat the interactions with large language model as an agent. So the agent will take the output of a previous round of chart and then use that to adapt their prompt or their input and then to interact with the model again. So I guess in your case, I think you copy and paste and assemble something and then make it a new input. Yeah, okay, something I think could be happening.
And one more thought. So what you might try is just have sessions by expert users like Mario or yourself or Manuel or whatever, and then just train the model on these sessions. So not ask it for the result, but ask it for the process, and then see what it comes up with. Let you see it making mistakes and correct and maybe.
Yeah.
Yeah.
I think if people are willing to, and then it could be a small program that Mario can turn on when he is doing his proofs, and then to record every keystroke input, and then use that to fine tune the link copilot. I believe the performance will be much better.
If he goes for coffee, the model also will have these breaks. Because it's irritating. What's the reason?
I said the model might get tired.
Sourcing, I guess.
That actually does, this is one thing that seems to be missing from the current crop of LLMs is that they don't do machine learning anymore, right? They're just sort of pre-trained and now you don't do learning and they do what they do. Like, back in the day, I thought that the whole idea was that they would
I don't
learn,
know.
right?
You probably know this. I don't know this. I don't have a ChatGPT subscription because I fear I would play with it too much. This is to keep me down. But you can select all these models from a list. Can you also make your own models in this style? I just don't know.
I think we can.
How does that work?
I think there's an option that we can fine tune using some.
But how does that work? I don't know. Just a question.
It's just, I think it's I haven't used it, but I believe there's a paid option that allows you to give some it's quite expensive, but allows you to fine tune the model. It's not easy.
I don't know whether that would be.
Yeah, maybe in the future, I guess we can all. So there's a 7 billion model, which is a model that can fit in a single GPU card, and I believe I think there's quite a lot of research around this median-sized model, and then I hope in the future we can deploy these models locally, and then we can play with them in whatever ways we want.
Yeah.
So I posed this question before informally, but I think what still puzzles me is how much language models could profit from parallel data, because the language model by definition is not for parallel data. But the thing I have in mind for my the things that we are doing in GF is that one could use it to synthesize parallel formal use it to synthesize rather rich informal proofs that are strictly parallel to formal proofs.
Yeah, we did that with MMA, but it was not for proofs, it was for statements.
The thing is that so I would like to do it in a way that is
Scalable.
yes, and also let's say sufficiently rich so that it covers the ways in which natural language is actually used in mathematics. Because then, so the initial idea that I had a long time ago and hasn't still quite been done is that one could use this to help auto-formalizing existing natural language proofs, and then those formalizations could be used for training whatever.
I think,
Well,
yeah,
it's statements, not proofs.
yeah, we were only doing it for statement, and we were
Yeah.
informalizing existing formal proof,
Yes, yeah.
and then a formal statement, and then to create a synthetic data set. But then with these models, we can create synthetic data set in a lot of ways. So if I understand correctly, what you are proposing is to formalize, to auto-formalize some informalized proof. Auto-formalize some informal proof to create a synthetic data set.
Yeah, so I think both right directions would
Both
be relevant, but
Yeah, but again, so it's about the quality. So again, as I mentioned, informalization is much easier than formalization. So if we informalize a formal statement or proof, the performance is just will be of better quality. If we formalize these informal ones, the quality will be lower.
Yeah.
But also, if you informalize in some very simple way by using a very restricted controlled language, then you can get a very good representation of what is used in actual mathematical language. But does it matter in?
Yeah, no, because we created for each formal statement,
Yes.
we created 100 informal variants of it for the.
Created them manually?
No, with the language model. We did the informalization with the language model.
Yes, so how did you know that those natural language statements were?
How good they were,
corresponded.
yeah. So we did some metrics to assess the quality of the informalizations. And because it's a language model, obviously, what did we get? 70% accuracy, or maybe even more, which is, like considering that you didn't have any of it before.
No, but would it matter if you
70%? 70% is mathematically correct?
Yes.
Accurate to the.
Yes. The informalization was done correctly for 70%. We did manual inspection of a sample.
But did you use that result for training then? Or
We did, yes. Yeah, for fine tuning.
In a corrected form or?
No, we used we didn't remove the incorrect ones, did we, for fine tuning?
No, okay, so then the question is, I'm just curious about if you had a way of generating 100% or 95% correct informalizations automatically, would that be useful for?
Oh, very. Very useful.
Yes, because that's what I think would be realistic.
But would you get enough variety and diversity?
Yeah, so this is exactly what I would like to work for, is that there is...
I think so. I think that would be super useful. So in many of the machine learning tasks, people are talking about data augmentation. So if even in images, simple image recognition on the mini data set, and the data augmentation is again some rule-based, like rotation or reflection. So they just change the image a little bit based on some rules, and then have extra data, and so the trained model the final model will be more robust. And then I think in this case, with this like parser, like you build, and then we can kind of doing data augmentations, and which will surely make the performance better.
That's encouraging. So my primary use case, as I said, is to document mathematics and do it in a kind of pleasant, readable way in Wikipedia articles or something. But another use case would be this that I know less about, but I thought that it might be.
Yeah, sure. It will be super useful. And it's kind of data augment the existing data set in a much more complex ways than the previous, like simple rotation, something. They are very simple, but then in your case, you are having a like symbolic, like sophisticated symbolic system that can augment existing data set.
What do you mean when you talk about parallel data? Like my impression of that statement was something like you have a very fine-grained, like word for word, like this corresponds to that, this corresponds to that kind of alignment of a statement. Is that what you mean, or are you talking like double paragraphs or full?
The whole statement, well, the way we did it is the whole statement in natural language and the whole statement in formalized maths.
Yeah, I think, so if you think about that you need these non-compositional transformations, then statement by statement is more appropriate than word by word, so to say.
Yeah.
But if it is compositional, then it's word by word, but it doesn't get this richness that you want to have in natural language stuff.
Think about this. Oh, sorry. Yeah, think about this problem. So it's word by word will not make sense, and so we need at least a statement by sentence by sentence, or even probably it's maybe the whole statement.
What do you mean word by word would make sense?
So if we want to translate it into lean, so if we are
Well, so what I was thinking was more along the lines of like with this controlled natural language business, it's like to what extent can I actually understand every single word that appears in this text, right? One of the things that I wanted to ask you was like, to what extent do these models produce something that's grammatically incorrect? My general impression is that it's like nearly 100%, like almost all of them.
Almost correct, yeah.
Well,
we didn't check, but.
Yeah, exactly. I suspect that if we started deploying some kind of controlled natural language, we'd find out all the ways in which it says something interesting. But yeah, like trying to figure out exactly how controlled does the natural language have to be when processing this kind of text.
Moa, you wanted to know more about something about.
I forgot what I asked you before, I think. Sorry, it's the coffee break, so I've forgotten what my question was now. But maybe about this. Are you thinking of going for? I mean, this is kind of verbose description. So have you done anything where you go from this to some sort of cleaner description that removes all this stuff about Harry and the Bank of Bath and coins and all this actually relevant stuff?
No,
yeah, so,
we're into automated reasoners.
Okay, so no, but I'm thinking if you want to take on this is a challenging statement because it contains too much other stuff.
Yeah.
So is the idea to go from this to something that's somewhere, I mean, something like your informant, what do you call them, the sketches? But is it doing that already? Or?
No.
Okay, but that's the next step.
Could be, yeah, one of the next steps. Yeah, I'm here just showing a very hard example.
Right.
Yeah, how much of this works on like archive proofs and things of that, or textbooks? You know, the kind of mathematical content that I think the people in this room want to auto-formalize.
So you mean auto-formalizing beyond computation level problems?
Yeah. These are all sort of very elementary, and there's a lot of data on them, and I'm really worried that like this isn't going to transfer at all, and like, well, once if you try to run something that's trained on this kind of material on like group theory, maybe it's just not going to work at all.
Yeah, I think it's there's at least two. So even in Lean, so by Danja, and we have this file or something like undergrad level evaluation benchmark in Lean, so informal and formal, and also I'm trying to port this to Isabel. I think it's not that bad. Again, informalization is better than formalization, and the whole formalization, the main bottleneck is still about definition. So with like computational problems, definition usually they are fixed. There are only a handful of definitions. Maybe this is something else. Maybe to formalize this, we may need a new definition, but that is completely not possible right now. So, but then with these undergrad level problems, I think the hard part is to retrieve the right definitions. Other than that, I think is still very possible. The performance is not that bad.
Also, we need serious data sets for benchmarking how well auto-formalization is doing for various domains, and we just don't have them.
Yeah. We're still in the process of building the benchmarks, and also with this auto-formalization, we are doing few short learning, so we'll need some demonstrations, and if we go beyond competition, and the mathematics, they have diverse area, number theory, algebra analysis, so we need some in-domain demonstrations to have the best performance.
Would it work to just take a text, like a standard textbook, open source, and then just try running it on all of the proofs in it, right? That would be very representative of what people imagine when you talk about auto-formalization.
You mean the proof was the statement, or just
No, I'm saying like you take a textbook, the entirety of the textbook, and then you train on all of the theorems and proofs and content. Yeah, you just train on everything in the book.
So you train books? Where do
you train on formalization, informalization, like trying to produce formal proofs from that. Auto-formalize the book, basically.
Yeah, sure. But
and I imagine the performance isn't going to be that great, but then it gives you something to work for.
Just do proofs from the book because it helps Joseph with his data.
It's I think we actually just right after this one. So we tried something. We don't think it's there yet. So recently we have this with Manu and Larry, we have this formalization project of these modular forms in Isabel. We finished half of the textbook, this Apostle modular form textbook. Actually, in this project, we were trying to do some initial experiments to use large language models to formalize the statement and then to synthesize definitions. But again, this is the graduate level textbook, and I don't think it's there yet. Some of the definitions, they are just too hard, even for humans. So again, I don't think we are there yet. Maybe for undergrad, some maybe classic analysis. So with a lot of corpus, I think it might be possible. Again, and also we need good benchmarks. Otherwise, we have to humanly do exam, and it's not scalable.
Well,
yes, I think Wenda partially answered the question while I was waiting. It looks like one of these big holes and big challenges then is in auto-formalization, formalize some new definitions. So a lot of these problems, they are in these need numbers and nothing too fancy. But there seems to be a big unexplored space of synthesizing definitions, perhaps, or maybe changing definitions. So Mateja would know about work in Edinburgh where they were trying to change representations for changing formal representations because of something didn't work out or something. But that seems to be very unexplored in this area.
Yeah, I believe so. So to me,
it's very difficult as well, but maybe, I don't know what methods, maybe there would need to be more with symbolic, or near symbolic.
Yeah, to me it's
or
really
interactive, or
yeah, it's simply too hard. To me, the conjecturing problems is the next step for proving, and then definition is another level where I have no idea how can we synthesize good definitions right now.
But I mean, there was some work on that in Edinburgh for representations and how to build them and modify them.
through critics, yeah.
We synthesize the definition for we
These are still generative, right?
Ursula.
Again, I was thinking about broader sources of problems to look at. And one might be looking back at more historical archives. I mean, I'm thinking, for example, in the early days of group theory, people were writing a hell of a lot of very trivial things, let's be honest. But, they might be just the sort of thing. There was a mathematician at the turn of the 19th century, Dixon, I think his name was, And it seems like every Sunday afternoon he sat down in his armchair with his pipe and wrote a paper on group theory. And these are generally pretty trivial, what like modern standards, but it would give you a big, kind of big training course in an area. And you see, it's not just focused. If you take textbooks, somebody has put the line through. You know, a bottle doesn't have too many diversions. Whereas Dixon was just thinking random thoughts about these mathematical, these different structures. So there's also things like Shannon's outline series, you know, which gives us a very basic theory.
So you're saying that the historical text is more diverse?
Well, I'm giving an example of historical texts where the mathematical material is actually pretty straightforward.
Uh-huh.
I mean, I wouldn't glorify this with the title historic, you know, these are not historical texts of great significance.
Okay, I
But
see.
they're large collections of papers with a diversity of trivial results in a small domain. That I think is how I would characterize them. And the point is, you know, then it'd be interesting to see, given all that different stuff, because I don't think Dixon ever followed one of these ideas through to a conclusion. He just sort of sat down, wrote a paper, and then thought, nah, and then sat down, wrote another paper about another thing. So it has very different characteristics from modern mathematics. And so as a set of mathematical examples and mathematical texts and concepts to explore, it would have a sort of breadth, you know, a breadth. I mean, you come on to the whole question, is any of that interesting? Well, you can't read Dixon's mind to know what's sort of interesting, but I think interestingness is a bit orthogonal to that, unless you can extract from it Dixon's thoughts.
Mhm. Yeah, interestingness is definitely a thing that we are definitely pursuing and trying to use in, I think, in computational terms, getting a more of a handle on that.
When you talk about like making definitions or conjecturing, this feels more generative than autoformalization
Yes.
should be, right?
So we are using conjecturing. We have projects, and we were just talking with Moa about this too, where we use conjecture generators, and then and then do the autoformalization with the new conjectures and see whether we can improve the performance of theorem provers. And we found that basically the symbolic ones we haven't been very successful with the symbolic ones, mostly because I think that the theories that the theorem provers are good for are not in the domain that these conjecture generators are generating. Like we used the inequalities generator and stuff. So AFP and MATLAB, they're not very good at doing that. But then we used a large language model to generate conjectures, and it generates tons of like really uninteresting stuff, but who cares, because you can feed everything, right? And did autoformalization, and we were much more successful with that.
But I guess what I'm referring to is more specifically like when you're doing autoformalization, or at least I have some impression that there's like an informal text, and you don't need to invent a definition. It's written right there.
Yes.
Right? So it becomes a question of like how well can you transcribe a definition that's been written in natural language with some stuff omitted and whatever, as opposed to how do I just invent what I think they ought to have said or something like this, which seems like a much harder problem, right? Especially if I want to make the rest of the book make sense.
Yeah. I think some of the stuff from Edinburgh, from the proof planning and the critics on lemma generation there, this is totally symbolic way of doing it, could be interesting. Because there's generic methods of how to approach failed proof attempts with lemmas. How do you get the hints from the failed proof attempt to generate the lemma? So this work is old, but I think some inspiration could come from that for the lemma generation, for conjecture generation.
Yeah, so in general, I believe there should be a distinction between retrieval and invention. So if there's an informal definition out there and then just to retrieve and then to formalize it, I think that is not hard. But in many cases, so say in this particular problem, to formulate this problem, we'll need some probably a definition about a list, some like inductive definition or sort. So if we want the model to introduce such definition in order to describe this problem, I think it's hard.
Did you have one of your many papers? Didn't that do some sort of retrieval augmentation, or did I?
It's one way. So I have either step paper where we have like 2 steps and then to conjecture one in the middle. Yes, some.
I was thinking if it's like, for instance, if you need some force on definition or something, or maybe that.
Yeah, that may be a good step for like conjecturing.
Yeah.
So yeah, and we have maybe some signals to reinforce the conjecturing abilities of the agent. Yeah, I think I haven't
So
pushed that.
Okay, maybe this was in lead.
Okay.
It's like enough to
Yeah.
getting things mixed up. But I think in lead there is something like that, retrieval augmentation,
And more.
Yeah, the lead people. Isn't it something with retrieval augmentation? Maybe that's not for autoformalisation, maybe that's for proof text generation. So is it something like that? You know that, right?
Yeah, so I mean, there are a number of projects.
Yeah.
So there's Vito,
Yeah.
well, I mean, like,
Yeah, but it's in particular with so when you go and fetch some say review reports, hearing it, that sort of thing,
So,
to maybe augment the prompt or to use that in proof.
yes, I don't know I know LLM stuff.
Okay. I'll
But
yeah,
Do you know the
maybe
answer
that's
to
what
this problem? Do you know the answer to this problem?
I know some humans try to formalize this, but it's not public. Yeah, but I didn't try to solve this problem myself.
Any more comments, or shall we go for early coffee break? Coffee.
There is already cake.
Definitely, coffee and cake. Thank you very much.
Thank you.